I hope, whether you remember or not, but you should have seen an equation that if you know 2 points and you need to come up with a line that goes through those 2 points, we have a specific equation that solves for that line. And that equation is called your point-slope form. The point-slope form is going to be y minus y1 equals your slope m times x minus x1. Where y1 and x1 are some point that's on that line. So if we look here, you would have numbers there. I would have a number here and a number here, and I would solve for the slope. And then what we're going to do is we're going to solve for y. Because if you don't remember this form, you should at least remember point-slope form, right? Kind of. Y equals mx plus b. Does that ring a bell, I hope? That's what we're going to actually get down to. So this is, if I know a slope and I know a point, I can use this to put in a slope-intercept form. We can get there. All right? This is a very handy equation. It's good to know. You're going to need it for Algebra 2. You're going to need it for pre-calculus. It's a very important equation that you're going to see a lot. All right, so let's do an example. It says, find the equation of the line through -1, 4, 2, 3. Solve for y if possible. It will be possible. It should just say solve for y, probably. All right, so it says, find the slope to start off with. So slope could be the tricky part of this. The point should be easy. The slope should be the hard part. Your slope, does anyone remember anything about slope? Yeah. Movement up from one point to the other. Does anyone remember rise over run? Rise over run. Your slope is rise over run. As you move on in your math career, you're going to say less and less of rise over run. Rise. Rise are your y values. Y runs up and down, right? And x values run left and right. So if I picture an xy plane, we have x is going this direction, and we have y is going this direction. So your rise has everything to do with your y values. In fact, it is called a change in y over a change in x. That delta in math stands for change. So we're saying change in y over change in x. Well, change in y is how high does it go up? Change in x is how far left or right does it go? To calculate those, you're just going to do your y values subtracted over your x values subtracted. You have to know this equation. You have to know that equals your slope. Slope equals change in y over change in x. In other words, your y values subtracted, your x values subtracted. Now, pay attention here. There is no mathematical principle that says this is my y2 and this is my y1. There's nothing that says that. Generally speaking, we take whatever second point is, we call it our second point. We take whatever our first point is, and we make that our first point. The only thing you have to concern yourself is, see how this is y2 over x2? If I choose this y value of 4 and I plug it in for y, that means the -1 has to go underneath it. So as soon as you pick this as being your y2, your x has to go right underneath it, which means this is going to be my other y, and the other x is going to go right below it. So just make sure your points are right on top of each other. This 4 and -1 will be on top of each other. This 3 and 2 will be on top of each other as well. Then it doesn't matter which point you pick first. So in this case, I'm going to pick 3 to be my y2, which means right below it must be the x value that is assigned to it. So that would be 2 underneath it. Then you're going to subtract your other y, which is 4. And then we're going to subtract our other x, which is a -1. Make sure you use parentheses to recognize that it's minus a -1, which then turns into a positive. It turns into a positive. So our slope is now going to be 3 minus 4, which is a -1, over 2 plus 1, which is 3. Our slope is negative 1/3. So now we have the value that's going to go right here. If we read here, it says use the slope and either point to find the equation in point-slope form. So we can use either one of those points and that slope, and we're going to come up with the exact same equation. So, for example, someone pick one of those 2 points. I have negative 1,4 and 2,3. Someone pick one. We're going to get the same answer. Yeah, 2,3. So we're going to go ahead and use the point 2,3. So remember, our equation is y minus y sub 1 equals slope times x minus x sub 1. Well, we're going to take the y value that Tori picked and plug it in for that y. We're going to then take the x value and plug it in for that x sub 1. And we get the slope from up above. So we're going to have y minus 3 equals our slope of negative 1/3 times x minus my x sub 1 value was 2. Now it says solve for y. I kind of do this the same way every time. If you choose something different, so be it. I distribute this negative 3, and I add 3 to both sides. I do that in one step. So I'm going to distribute, and I'm going to add 3 all in one step. So we're going to move up here, and we're going to say, well, that's going to be y equals, well, that's negative 1/3 x. Negative 1/3 times a negative 2 is a positive 2/3. And then we add 3 onto the end. 2/3 plus 3, that's something I can do. What do we need in order to add fractions, though? There's something we have to create. Yeah, Leanne. We need to have common denominators. We're going to use common denominators. So what I'm going to say is, well, I want 3 to have a denominator of 3. So I'm going to rewrite 3 as 9/3. Well, now we're going to have y equals negative 1/3 x plus 2/3 plus 9/3 is 11/3. Now let's reverse time for a second. If Tori, when I asked that question, what point should I pick? If Tori would have said, choose negative 1/4, I would have plugged negative 1 in for this x. I would have plugged 4 in for that y. I would have solved for y, and I would have came up with this exact same equation. It didn't matter which point Tori picked. We would have ended up with y equals negative 1/3 x plus 11/3. If you don't believe me, do it. And you can do it on the next one, because I'll pick a point, and you pick a different point, and see if it comes out the same. So we're going to move on to the next example. Next example says, find the equation of the line through 5,2 and negative 4,3 and solve for y if possible. It will be possible. So our slope is m. I'm going to pick 2 to be my first y, which means 5 has to go underneath it. 2 and 5 have to be matched up. Then we're going to subtract the other y, and I'm going to subtract the other x, which turns into a negative, or a minus negative 4. All right, 2 minus 3 is going to be a negative 1. All over 5, well, that's plus 4 is going to equal 9. That's our slope. Negative 1/9 is my slope. Can someone pick one point for me? Yeah, Sam. 5,2. If you don't believe me that they're going to come up with the exact same answer, pick negative 4,3. Or if you believe me, just do 5,2 with me. So I'm going to do the point 5,2. You do what you want to do. We should get the exact same answer. So I'm going to pick 5,2. 5,2 is going to lead to the equation where you have y minus my y value is 2. So once again, we take that y value first. Our slope is negative 1/9. And we're going to multiply that by x minus the x value I get from the point. And now I'm going to solve. To solve for it, I'm going to distribute the negative 1/9, and I'm going to add 2 to both sides. That's going to give me y equals a negative 1/9 times x plus, so I have negative 1/9 times a negative 5 is going to be plus 5/9, and we needed to add 2 to both sides. So I took that 2 and went Boop, put it on the other side. I need to create a common denominator. How can I rewrite 2 so I can add it to 5 over 9? What am I going to rewrite 2 as so I can add it to 5 over 9? All right?
18 over 9.
We'd write it as 18 over 9. So I'm going to rewrite 2 as 18 over 9. All right, so now when I do that addition, we're going to have y equals still that negative 1 over 9x. But I'm at 5 over 9 plus 18 over 9 is going to be 23 over 9. Did anyone pick the other point, or did we all go with me? If you would have picked the other point, you would have got the same answer. If you would have had the drive to do it. All right. Example 3. Yes, Cam.
Wait, aren't you actually turning the 2 into an 18 over 9?
How do I turn it into that?
Yeah.
Because they have to have a common denominator. So they both have to have a denominator of 9. What is 18 divided by 9? 2. So I'm just rewriting 2 as 18 over 9 so that I can add those two together. They have to have a common denominator. Yes, yeah. Yeah. All right, this next point, they didn't give me 2 points, so you have to come up with your own 2 points. And you probably want to pick ones that are even, right? So let's look here. So I'm looking at the line. I'm looking at the first time that it actually hits one of these x's, which is right here. So that point, 2, 9, is a point on the line. Can someone find another point that's on the line? Brendan? 5, 10. That would be the perfect next one. Why go way out when the one's right there? Now we have the same problem we just did up above. It says, find 2 points. I have 2 points. Now write the equation for that line. So we have our 2 points. So we're using points. We're going to use the points 2, 9 and 5, 10. Our slope is going to be our y. Let's pick 10, or you can pick either one. You can come up with the same answer. Either you pick 9 or 10, doesn't matter. You can get the same answer. Just make sure your pairs line up. So I have 10 and 5 lining up, minus 9, and the 2 would be on top of each other. All right, 10 minus 9 is 1. 5 minus 2 is 3. Our slope is 1/3. I'm just going to pick 2, 9. If you want to, try 5, 10. I'm going to pick 2, 9. So I'm going to use 2, 9 to write my equation. So we're going to have y minus 9 equals 1/3 x minus 2. So once again, I just picked that 2, 9 at random and used it for there. All right, next step is we're going to have y equals distribute that 1/3. Well, that's going to give me 1/3 x minus 2 over 3. And then I'm going to add 9 to both sides. So plus 9 to give me that plus 9. Cam?
Shouldn't it be y minus 2? Like y minus 2?
Our y value is 9. Our x value is 2. Okay, now I don't want 9. I want to have a common denominator. Yeah, Lisa, did you? You should reduce it. Like yes. So if you got 3 over 9, I'd reduce it to 1/3. Yeah. All right. I have 9 and 2/3. What am I going to change 9 to so I can add it to 2/3? Shauna. 27. 27 over what? 3. 27 over 3. There we go. So we're going to turn this into 27 over 3, because 27 divided by 3 is still 9, which is going to give me y equals 1/3 x negative 2/3 plus 27 over 3 is really 27 minus 2, which will be a positive 25 over 3. That is my equation for that line. Questions on taking 2 points and turning it into a line? Equation for a line. It already was a line, but we're good on that? All right, then we're going to apply it to statistics now. We had to look at that so we could do this next problem. I'm skipping interpolation and extrapolation just for a second. We'll talk about it when it arises in the question. So I know I'm missing a slide. All right, so it says, the data below displays the amount of time LeBron spent on the court and the number of points he scored. We are going to draw these data points, and we're going to draw a regression line, and we're going to come up with the equation for that particular regression line. So the first thing is, I made this too big for you guys. I think when I was resizing it, because what needs to go here? We need the data and a title. So there's not really much room for both of those. So I'm going to kind of cheat and just put a little arrow and say, well, on the x-axis, I'm going to go ahead and put minutes. And on the y-axis, we're going to go ahead and do our points. So that means minutes are x's, points are our y values. All right. Now, look at your time in the game. We have to go from 0 to 40. Would it be smart to count by ones? No, I don't. I guarantee there's not 40 lines on there. So let's try counting by twos. If that doesn't work, count by fours, count by threes, count by fives, whatever works on that particular data. Twos will work on this one though. So we're going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, and 40. If this was me writing these out, I'd probably not write every one of those out because it gets a little smushed when you have that many numbers. So a lot of times when it's really small spaces between it, I'll skip every other one. So I'd probably write 2, 6, 10, 14, 18, just to make it a little clearer. But there's no rule that says you need to or not do that. So do whatever makes sense to you. Just make sure you have some kind of scale. All right, for points, I have to get all the way up to 21. Yes, Hamza?
If you did that, wouldn't you jump from like 0 to 2 to 1, but then have like a space?
Well, I just wouldn't label each of these. It would look just like this. It would look just like that, where I have 2, 6, 10, 14, but I know 4 is here. I know that 8 is here. It's just, it can keep stuff a little cleaner. Especially when you have like 3-digit numbers and you have to like push them all together. If it starts getting really pushed together, just start skipping every other one so you have space to write each one. All right, so for points, I need to get all the way up to 21. I probably have to count by twos as well. So hence, it might look something like this. I might go 2, 6, 10, 14. See how the spacing's still there? Like there's room for it, so I could put 2, 4, 6, 8, 10, 12. So I didn't change anything. I'm just leaving some numbers out to make it a little neater and more organized. 16, 18, 20, 22. Did I miss something? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. All right. Now let's plot all that data. So when he plays 0 minutes, he scores 0 points. What a weird stat. All right, when he plays 4 minutes, he scores 2 points. 4 goes to 2. 8 goes to 3. 12 goes to 5. Looks like 16 goes to 10. What's the next one? 20, 12. 24, 12. 28, 16. Looks like 32, 16. 36, 16. And finally, 40 is 21. Give you a second to make sure you have all those plots done. And my stomach to rumble, apparently. No one heard that? Okay, I was going to say, it was pretty loud. I think because I only had like a quarter of this so far. Would you say this is a strong relationship or a strong correlation? I would say it's pretty strong. So where it says, how would you describe this correlation? We'll get to what Hemza said. So we can say, is it positive or is it negative? It's positive. So we could put this in words. We could put, hey, it's positive and strong. Or, like Hemza said, if you know your R values, you could say R is about, does anyone want to approximate that R value for me? Aryan? 0.9, 0.8, 0.9, somewhere in there. Yeah. So we'll go with Aryan's 0.9. I would personally pick 0.8, but I don't think there's anything wrong with 0.9. So what Hemza was asking before is, can you tell it's positive from 0.9? Can you tell it's a positive correlation? Can you tell it's strong? Do you need to write both of these words? Probably not. If I ask you to describe the correlation, you can just go, R is about 0.9, and I know what you're thinking as long as you know what R values are. If you're not sure, if you're like, oh, I forgot which happens with R values, then go back to the word and say it's strong, positive. Okay? The next thing it says is you're supposed to draw a regression line, and then you have to come up with the equation for that regression line. Are we all going to draw the same regression line? No. So we're all going to come up with different equations for that line, especially on the homework, right, Cece? Especially on the homework, we're going to have different equations. For these notes, I want us all to have the same equation. All right, so what I want you to do is I want you to make sure your regression line is going to go through the point 0, 0. And what was the other point I wanted it to go through? I don't even have my notes anywhere near. And then I want it to go through the point 16, 8. That means we're all going to have the same answers from here on forth. On your homework, you're not all going to have the same answers. Your answers aren't going to match mine. My advice to you is when drawing a linear regression line, make sure it goes through at least 2 points that you know of. So on the homework, you're going to draw your regression line. And you're going to find 2 points it goes through to find the thing. I picked 2 to start off with. I picked off 0, 0 and 16, 8. So we're going to use those 2 points to come up with our equation. So I specifically chose this line. Yours might have been different on the homework when we do it. So we're going to have 16, 8. And now we're going to come up with the equation for the line that goes through the points 16, 8 and 0, 0. All right, let's go down to that problem. So it says we already drew the line of best fit. Now we're supposed to come up with the equation. Well, our slope is going to be our y2 minus our y1. I'm going to pick 8 to be my y1, or y2, which means I'm going to put 16 right underneath it. Then I'm going to pick my other y value, which is 0, compare that to the other x value, which is also 0. So that's going to be 8 over 16, which is just 1/2. Now I have to pick a point to plug in so I can come up with my equation. There is, in this one case, one point that's a lot easier to use than the other point. Does someone want to guess at what point I'd probably want to use? Yeah? I would use 0, 0. Because when we plug in 0, 0, we don't have to do much work after that. So we're going to pick the point 0, 0, which will lead us to y minus 0 equals our slope of 1/2 times x minus 0. Well, I don't have to do any of the subtraction. I'm just going to end up with y equals 1/2 x. If I were to pick the other point, I would have still came up with y equals 1/2 x, but I would have had done some math. So if 0, 0 is an option, always pick it. It's the easier ones to use. All right, the first question says, what is the real-world interpretation of the slope we came up with? Well, our slope we came up with was 1 over 2. Yeah, sorry.
I have a question about the 68. Did you just randomly pick it, or is there a reason?
Oh, I picked it so we'd all have the same numbers. But like I said, if you would have just we all would have had different lines. Maybe your line, if you picked it, would have not gone through that point. You would have picked a different point. So my advice to you is when you're drawing your regression line, don't do it randomly. Pick 2 points you know it's going to go through, and then draw it through those 2 points. That way you're not all of a sudden drawing it and finding that there's no points it actually goes through. Like when I was drawing this, I actually picked these 2 points out and said I'm going to draw a line through it so that I know which 2 points I'm going to use. All right, so you could pick your points beforehand, but make sure you're not skewing it. Don't pick, I'm going to pick 14.2 and then just stick with it, because that definitely wouldn't be a regression line. Make sure it still goes through the data, but it's a good idea to pick 2 points to start off with so you know for a fact it's going to go through 2 points. And then notice I'm forcing you to pick the ones I picked, in short. All right, so our slope is 1/2. Remember what slope is. Slope is change in y over change in x. In other words, your top of your slope are y values. The bottom of your slope are x values. So when you're talking about slope in real world, you have to ask yourself, what is x value standing for? Well, our x values are standing for our minutes played. What are our y values? Our y values are our points. So if I go back to this, our y values are our points, and our x value stands for our minutes. So what our slope is actually saying, for every 2 minutes he plays, he's going to score 1 point. So for every 2 minutes he plays, he's going to score 1 point. That's exactly what the slope says. For every 2 minutes played, played. Exactly, I think I worded it the same way. Yeah. For every 2 minutes he plays is probably a better way. For every 2 minutes he plays, he scores 1 point. All right, then the next one says, how many points would LeBron score if he was in for 22 minutes? Are 22 minutes our x values or our y values? They're going to be our x values. So we're going to plug 22 in for our x. So we are going to plug it into our equation. We're going to have y equals 1/2 times 22 would equal 11 points. Now let's talk about that next question. The next question asks, is it interpolation or extrapolation? You have some information about that above this, but we're going to talk about it within our data. Interpolation. Interpolation is data that is found within the data points given to us. So if you look here, the lowest time given to us is 0 minutes. The maximum amount of time is 40 minutes. So if I pick any time between 0 and 40, that is called interpolation. It is between the data that was given to me. Same thing with points. We go from 0 to 21 points. Any points we're talking about between 0 and 21 is interpolation. I look at my lowest data point to my highest data point. Anything in between is called interpolation. Anything that's outside of our data. So think about 45 minutes, 50 minutes, 100 minutes. These are all past that last data point. That is called extrapolation. Extrapolation is much more of a guess. So for extrapolation, you're not only saying it's about this time, you're saying if this trend continues. We don't know for a fact that this trend will continue. So anytime we get past this, we are saying if this trend continues, then it will be about. So extrapolation is weaker than interpolation. Interpolation between our data, extrapolation outside. One more time. Extrapolation is weaker than interpolation. Know that. All right. I like all the people that didn't write anything down. That's amazing. Good luck on that question on the test. All right. So is this interpolation or is this extrapolation? Yes.
Interpolation.
It'd be interpolation. It's between our points. So this would be interpolation. All right, how many points would LeBron score if he was in for 60 minutes? We already said that 60 minutes or minutes was our x value. So we're going to go y equals 1/2 times 60, which is going to equal 30 points. Would this be extrapolation or would this be interpolation? Brendan, it'd be extrapolation. Would that be stronger or weaker than interpolation? It'd be weaker. Yeah, thank you. Extrapolation. All right, last one says if he scored 40 points, points are our y values, right? So if he scores 40 points, I'm looking at my y value. How long was the game? So we have to replace our y value with 40. So instead of replacing our x, we're going to be with 40 equals 1/2 x. So we're actually solving for x this time. Well, to get rid of that 1/2, we multiply by its reciprocal, which is 2, or 2 over 1. So I'm multiplying both sides by 2. So we should end up with x equaling 20 minutes.
Wait, shouldn't it be
80 minutes, yeah. Oh. I don't know how he's going to score that many points in 20 minutes. Yeah, so it's 80 minutes because you multiply by 2. I don't know why I said I'm multiplying by 2 and I decided to multiply by 1/2. Yeah, we multiplied both sides by 2. That's what happens when you don't write stuff down, right? So let's go ahead and write down that I multiplied by 2 over 1. Distribute. Now we have 80 minutes. All right, any questions on what we learned today? All right, let us look at our homework really quick because I'm going to say this once again. Your answers are not all going to be the same as mine. On the first few, they will be. So on number 1, 2, 3, 4, 5, 6, 7, 8, we should have the exact same answers. When we start getting to you plotting data, you picking a line of best fit, our equations are going to be different. What I want you to use the answer key for is making sure you're plugging in the right x and y values. All right? So once again, our equations will be different. Don't change yours because it looked different than mine. Don't go, oh, it must be wrong. Just like with the r values, how I said our r values will be different. Same thing here. Our values are going to be slightly different. Don't cross something out because you have a slightly different value. Just make sure that you pick 2 points, you did your equation correct, and you plugged in the right x or y value. That's all we're asking for. Obviously, yours shouldn't be forever different. It's like we have chirps here. If I come up with 20 chirps and you come up with 6,000 chirps, there's probably a big difference. That probably isn't just you picked a different line than me. All right, guys, the rest of the time will be for you. Make sure you have your homework out so I can check that bad